Okay, everybody, I'm back here. Sorry, the lighting's kind of bad here. I'm just in a conference room again in Billings, Montana at the National Center for Appropriate Technology Harvesting Clean Energy 2015 conference. And I just gave a little lecture on glass repurposing. Realizing my glasses are kind of annoying. Well, that's probably even worse anyway. What I'd like to do next is just kind of catch up on the forum. I just looked into the participation. It looks like most people are logging in. I see most folks have been in the website in the last day or so. Some people a couple days. I think the longest time I've seen someone not be in the shell was maybe a week ago. So that's probably the maximum amount of time you'd want to go without logging into the shell. So I'm just going to drop into the forum here a little bit. Catch myself up. So there were a few unread posts from week 3, embodied energy, that I want to catch up on. So let's look at Brian Davis's aluminum and copper that he posted 3 days ago. And I want to say too that this is kind of the brave new world of education, online education, asynchronous learning, and don't be afraid, to go back and revisit some of the topics we've already discussed. A good idea can come to you really at any time, so you won't be penalized for posting too much content, so don't worry about that. I'll just take a look here. All right, so what Brian's posted on is embodied energy of a couple metals, aluminum and copper, stating that they're the most recycled after steel. However, these two materials are 100% recyclable without any loss of quality. This means further use will only embody the energy required to recover and recast them. Also pay well for those willing to recycle them. Sounds great. Prices fluctuate. Okay, so steel is down at 4 cents a pound, aluminum 33, and copper at 50 cents. So I believe this is recycling rates, although aluminum is fairly resistant to erosion, contamination, recycle both materials. Yeah. Okay. So what I've found, and in fact, I don't know if I've got anything on me here. I was just drinking some coffee earlier, and there's the little tiny creamers, and we've done some testing, and there is a little bit of aluminum sitting there in the lid of that creamer. And that's one big issue with zero waste strategies. How do you recover that aluminum in a cost-effective manner? In the case of those plastic containers with that little bit of aluminum, what I think we're probably going to be moving towards is a gasification or a pyrolysis unit where you're heating that composite material, the plastic and the aluminum, to a temperature where the plastics off gas, ideally to a pure CO2 level. That CO2 is then captured and repurposed for greenhouses. The aluminum is left behind, and then through conventional smelting processes, you would then recover that aluminum. If there are other metals mixed in, then again, just through conventional smelting, you would be able to recover. So a little bit more embodied energy, perhaps, but on the other hand, you're recovering the energy from the plastics. You've got all the metals in one place rather than a giant messy wad in the landfill. So again, I think the numbers that Brian is looking at here are for more pure metals. You can think of copper wire or a chunk of aluminum coming out of a machine shop. But
you're really involved in stakeholder involvement.
Nevertheless, that's what we're looking at. Okay, so somebody just turned the sound on. I'm going to pause the lecture and move over to another room. 1 second. Okay, I'm back. I think I found a quieter corner here to continue on. So again, Brian, thanks for those numbers. And again, all of these figures will go into go into the recoverable dollars, and I think we've already gone through a few numbers showing that it's on the order of $4 million worth of recoverable metals like this that go into the Missoula landfill every year. So not a trivial amount of material and money that we're just kind of piling up in a big mess. Okay, let's go back. Embodied Energy Forum. Steel and iron. Tynan, thanks for chiming in. So 25 megajoules per kilogram. That basically means if you, that's actually seems fairly small when it gets down to it. 25 megajoules per kilogram. I mean, that means that if I were to get on a bicycle for 2.5 days, I could come up with 2.5 pound or 2.2 pounds of iron. Not too bad, and it's going to depend on the quality of the bauxite and whatnot. For steel, we're looking at 20.1 megajoules per kilogram, even less than iron. Now, again, what I'm not sure about here is whether that steel, getting to the steel product itself, assumes that you're starting with pure iron and the other various materials that go into it. There's various high carbon steels that are going to have a higher carbon content to make them stronger. There are also a fair amount of alloys, vanadium being one, chromium being another, that goes into making stainless steels. So that I'm a little surprised to see that the embodied energy of stainless steel is actually lower than iron. So that's something for discussion. Found another website that showed how many kilowatt hours to produce. Right, so looks like you're more or less converting megajoules to kilowatt hours. That's a good sound conversion to make. Yeah, so it's funny. Jason's saying it sounds like a lot of energy. To me, it sounds like not as much as I would have expected. If I were to actually have to power this on my own. 2 days to make a kilogram. This doesn't seem not that bad, actually. Okay, lapis lazuli. When I see the word lapis, I'm thinking of somebody, doing some stone lapping. I'm not sure if that's where it comes from. Sounds like Rachel carries one with her pocket. Embodied energy. The embodied energy lapis encourages higher mental facilities, creativity. Interesting. Okay, so now you're kind of talking about more of a bioenergy, if you will, and I can't deny it. I am not a specialist in this field. I have to admit, but one of our graduates, when I was first talking about the various energies that we employ in energy technology, he said, well, you really need to tap into the chi, or the human energy, and it's something that I don't think a little bit about. But Rachel, if that's where you're going with it, I'd love to learn more about it. So a thought enhancer, higher mental facilities. It's something you could test. Maybe send me a chunk of it, and I'll see if my lectures get me better. Rock, not a mineral. Other components: feldspar, silicate, sodium, aluminum, silicon. So it's a mineral, composite, and chloride. Interesting. Okay, so I think what Rachel's saying here, the actual physical embodied energy making that stone, the lapis lazuli, was more or less from the formation of the planet. Those elements coming together, they were hot, they cooled, and there you have the rock that she's mentioning. I'm giving a lecture right now. I'll be with you. It's okay.
I'd like to visit.
Okay, yeah, I can. Okay, sure, thanks. But it sounds like what she's describing is this actually providing some additional energy. So I'm not going to throw the hypothesis out there. I'd love to talk more about it. So thanks for sharing that, Rachel. All right, so there's embodied energy, stainless steel. I think Sean showed that a little bit. It's like you guys are focusing more on the metals and the minerals here. Virgin material. Okay, so we just clarified whether we were talking about recycled or virgin. All right, so let's go back to forum. Again, I'm just going to take a quick pause here and be right back with you.